Hello, welcome back. In this video, we're going to talk about application to business. So the first concept I'm going to cover today is consumer and producer surplus. So what is consumer surplus and what is producer surplus? So by definition, consumer surplus refers to the differences between what consumer is willing to pay and what they pay for the product. Okay, so this is consumer surplus. So what is producer surplus? So the producer surplus is the differences that a producer that willing to accept a produce the price that the producer willing to accept a produced good and the market price. Okay, so here is the concept. So now let's do some recall. So remember, there is a demand and supply function. Well, for a demand function, if the price goes up, what happen? Well, if the price goes up as a consumer, you will less likely to buy the product. So that means the quantity of the product is going to go down. And then on the supply side, well, if the price goes up, you're willing to produce more product. So that means the relationship between the price and the quantity at the supply end is going to be an increasing function. Okay, so now if you look at this graph, so which one do you think is a supply? Which one do you think is a demand? Well, if it's an increasing function, I can say, hey, this is going to be our supply function, and for the decreasing function, we will know that, hey, this is going to be our demand function. And I let the horizontal axis to be the quantity. Of course, you can swap it. That's okay. And then the vertical axis is going to be the price. So now, what is the equilibrium point? And what is equilibrium point? Do you remember? That is from business pre-calculus. So equilibrium is when the price, the demand and the supply function is going to reach the balances that they produce that amount of the product and they all sell out, right? Which is at the intersection point. It's going to be the equilibrium. Let me use a different color. Equilibrium point. So let's say at that point, we're going to produce Q start of product and P start of product. So now here is our Q start, and here is going to be our P start. So okay, so by the definition of the consumer surplus, where do you think the consumer surplus is going to be? Well, the consumer surplus is the differences between the consumer is willing to pay and what they pay for produce. So what they are willing to pay and what is the market price, the differences should be here, which is, I should use a red pen, which is the line in between the equilibrium point to the demand function. Here is our consumer surplus. Well, so where do you think is going to be the producer surplus? Well, since the producer surplus is the difference between the market price and the lowest price that the producer willing to pay, so this area is going to represent the producer surplus. Okay, so how do we find that area? How do we find the consumer surplus and producer surplus? So now let's look at the consumer surplus. So from the consumer surplus, I know that it's going to be an area, right? Oops, sorry. So this area, if we find an area, we need to use integral. So the integral is bounded by what? From 0, this point, to Q star, right? 0 to Q star. And by the previous video, we talked about that. How do I find the area between two lines? Well, it's going to be the line from the demand function, whatever that is, and then subtract y equals to p star. So that means subtract as p star and differentiate at q, because our horizontal axis is q, quantity. Okay, so if we simplify it, we will get, okay, this is differentiate from 0 to p star, the demand function at the quantity plus this is p star times q. So either way, you can use this one or this one, they are the same. For the second one is I just pull the differentiate out in here because I already complete the integral computation. So that means I just need to differentiate the first part, which is the demand function. Now similar to the producer surplus. So for producer surplus, oops. It's going to be from the same x interval, which is from 0 to Q star, which is at the equilibrium point. And then it's going to be the y equals to p star, which is the black dashed line. So in order to make it more clear, I'm going to here, that's the black dashed line, to the supply function, which is the green line. So I have the p star subtract the supply function and differentiate at the quantity. So when we simplify it, I can just differentiate this part, which is p star times q, subtract integral from 0 to q star, and then the supply function at the quantity and dq. That's it. Now look at these examples. When we look at this example, they suppose a demand for product is given by dq equals to negative 0.8q plus 150, and the supply function is equal to 5.2q. For both functions, q is the quantity and p is the price in dollar. 1. Find the equilibrium points. So equilibrium point is the intersection between these two functions. To find the intersection, we want these two functions equals to each other. So for the demand function, I have negative 0.8q plus 150 equals to 5.2q. And then we can solve for q by plus negative 0.8 on both sides. So I got 150 equals to 6q. So q is equals to, we divide by 6 on both sides. So for the equilibrium point is when quantity equals to 25. Now we still need to find the price. Since we already have a q, So that means I can either substitute the Q into the demand function or the supply function. Since this is intersection point, so no matter which one you substitute into, they should be equal. So now I'm going to substitute this into the supply function. So this is equals to 130. So that means the equilibrium point is equals to 25 and 30. Yeah. 25 and 130, sorry. Now look at the graph. So in the graph, it would be more, you can visualize what does this look like. Well, I have a supply function, which is going to be increasing function and cross the origin. So this is going to be our supply function, which is equals to 5.2 Q. And we have demand function. Demand function is going to be a decreasing function. And this is going to be negative 0.8 Q plus 150. This is our demand function. And then equilibrium point is at 25 and 130. Okay, so now the part B asks about, hey, we want to find the consumer surplus. So the consumer surplus is going to be the area between the demand and the y equals to 130, the dashed line. So that means to find this area, I want to have the integral from 0 to 25. From the previous section, we learned that to find the area between these two bounded lines, we are using the above line to subtract the bottom curve, which is in this case is going to be the demand function subtract the equilibrium point, which is y equals to 130 dq. And the demand point is negative 0.8 Q plus 150 minus 130. So now simplify it. I got negative 0.8 Q plus 20 at dq. So to simplify, I got negative 0.8 over 2 Q squared plus 20Q from 0 to 25. Well, when you calculate that, you will find out that this is equals to 250. So that means the consumer surplus is 250. And this is similar to the producer surplus. So producer surplus, by the definition, is going to be the integral from 0 to 25, and then I use the dash line, which is y equals to 130, subtract the supply function, which is 5.2 Q at dq. Now I can just enter derivative this function. From 0 to 25. So that means this part, this producer surplus, is equals to 1,625. So there are other examples to ask you to find the demand and the surplus function, surplus value. So in this one, it's given you a function. Sometimes they will give you a table, such as this example. So in this table, they given you a function, and they want you to find which one is the supply and which one is the demand function, and they want you to find the equilibrium price and the quantity, and also find the consumer surplus and producer surplus at the equilibrium price. Okay, so in this case, if it's an increasing function, we know that it's going to be the supply function. If it's a decreasing function, it's going to be the demand function. So look at the first table. when Q equals to 0, 100, 200, when Q is increasing, the price is decreasing. So that means this is a decreasing function. If it's decreasing function, so that means the first function is going to be, so since the first table is a decreasing function, we know that this is going to be a demand function. So the second table, as the Q increase from 0, 100, 200 to 700, and the price also increase. So that means this is going to be the supply function. Okay, so now from the table, what is the equilibrium prices and quantity? So the equilibrium price and quantity is when the supply equals to demand. So that means in this case, when the quantity equals to 400, both the supply price and the demand price equals to 40. So that means the equilibrium is at the price 40 and the equilibrium quantity is 400, whatever unit it is. Okay, so now they want you to find the consumer surplus and the producer surplus. So consumer surplus is the function from whatever that is to the function at the equilibrium prices, which is the upper area. And I want to have the integral from 0 to 400 at the demand function, the area of the demand function, minus the equilibrium point, which is differentiate at Q, minus the equilibrium prices, which is y equals to 14. So I want to subtract 14 times Q. Okay, so now we need to use the second equation to calculate that. Why would we do that? Because we don't exactly know the demand function. However, we can use the Riemann integral sum to calculate the area for the demand function, and then subtract 14 times Q. Okay, so the Riemann sum means I'm going to use a blue pen, this area, and plus this area, and plus this area, and plus this area. So how do I know each area? I know that when x equals to 0, p is equal to 70. So that means here is 17. At this point, it's going to be 161, and that point is going to be 200, and then 53. And this point is going to be 346. And then, okay, this is not the best graph. And then at the equilibrium point, this is 414. So by the Riemann integral, we can use the left endpoint or the right endpoint to calculate that. So in here, I'm going to use the left endpoint. 200, 100. Okay, so in here, the first block, if I use the left endpoint, it's going to be, the width of each block is going to be 100 times here, which is 17. So it would be 17 times 100 plus the second endpoint, which is this block. It's going to be 61 times 100. And then at the third area, this part is also the width is 100 times the height, which is 53. and then plus the last one is 100 times 46. And then this is going to be the sum of this block is going to be the area of this integral. And then we need to subtract 40 times the equilibrium prices, which is 14 times 400. Okay, so after calculate this is equal to 7,000. So that means the consumer surplus is $7,000. But this is approximate because we know that if we use any left endpoint or right endpoint, you're only getting a approximate result. So we use a similar process to calculate the producer surplus, right? So producer surplus is going to be this area. Oops, sorry. It's going to be this area. And then again, we can use either left endpoint or right endpoint to calculate that. So now let me erase this part. So now we have different points. I'm going to label this point first. So and here I have 121. And the second point I got 200 and then 28, 300, and then 13.3. The last one is 414, which is our equilibrium point. And then by the definition of the consumer surplus, we have using the dashed line, which is $40 times P, which is the consumer 14 times P, that is the equilibrium point, minus the integral from 0 to 400, sorry. Add the supplied function. Again, we can use the Riemann integral to calculate that, which means you can either use the left endpoint or the right endpoint. Either way should be correct. So this is the total for block that you have in. So I have 14 times 400 minus the first block. It's going to be 0 and 14, which will give me, if I use left endpoint, I have a 14 times 100 plus 21 times 100 plus 28 times 100 plus 13.3 plus 100, which is equals to 6,400. So that means the producer surplus is about 6,400. So the next part of this video is going to be the continuous income stream. So before then, let's do some recall. So what is compound interest? Compound interest is defined by this function, p times 1 plus r over k. The power is r times t times k, where p is the principal. So principal means how much money you put in the bank. 1 is just 1. R is the rate. K is the compound frequencies. What's that mean? That means how many times you're going to compound within a year. If they say compound quarterly, so that means you compound the money every quarter. So that means totally you're going to compound 4 times a year. So K is equal to 4. This is the future value, which is what it's going to look like in the future. how much money you're going to get after t years, such as after 10 years. So t is equals to 10. How much money you will get if you put in that amount of money. Okay, the other way is compound continuous, which is principal times e, the Euler's number, to r times t, where r is the rate, t is the time. But however, this only happens but this is one of the life scenario, which means you just put the amount of money into the bank at one time, but you don't touch it anymore. You don't continue to put money, or you don't take it out until after 10 years, whatever time that you set to be. However, in the real life scenario is the money that you put in could be changed over the time, such as this month I'm going to put 100, next month I make more money, I'm going to put 200, and then next month I'm going to something happens, some emergency happen, I don't have that much money to save up, so I put less money in it. So the money that you put in, if is a trend, let's say we can graph it. So it's going to be a function. How can we compute in how much money you're going to earn in the future, and how much does these things valued right now? So now I'm going to introduce you a new formula, which is PV, which is the present value, is equals to the integral from 0 to the time that you put in the function f of t. F of t is the continuous income function, e times negative r to the t at dt. So now I'm going to label this. This is the percent function. What does that worth right now? This is the continuous income function. So what's the application in this one? Well, this can be, think about that. You're trying to invest a house, a land. You're not going to live in it. You're just trying to invest it. And then they tell you that, hey, the house is selling $400. And each year, the house price is going to appreciate 4%. Is that worth $400? Well, then you can use this function to check out by plugging in the rate, the increase rate, and what is the continuous income you can get from getting the house, such as you use it for renting for maybe 1,000 a month. So that means your continual income is going to be y equals to 1,000. You plug it in, and the house appreciate maybe 2% a year, and then you can calculate what's the current value for this house. Is that worth 400,000? I'm going to show you some example later. And the other new function I'm going to introduce today is the future value, which is equals to the present value function times e to the rt, whereas r for both of these functions, r is the rate, either increasing rate or decreasing rate, and t is the time. E is just the Euler's number. Okay, so this is going to be our first example. You have the opportunity to buy a business that will earn $75,000 per year continuous over the next 8 years. Money can earn 2.8% per year, compound continuous. Is this business worth the purchase price of $613? Well, so that means in this case, we want to calculate how much does this business worth it right now. So that means we can try to find out the present value. It's equal to the integral from 0, since it's in an 8-year time frame. That means from 0 to 8. And then the continual function means you're earning $75,000 a year. So that means your continual function is going to be 75,000. times e to the negative r is negative 0.028 times t at dt. All right, so the first step is you need to integrate this function. Integral this function. I pull out the coefficient from 0 to a e to the negative 0.28t at dt. You can use the u substitution, which means I let u equals to negative 0.028t. So that means the derivative u at t equals to negative 0.028. So our dt is equals to du over negative 0.028. Now, I substitute these into our integral. I have e to the u. Dt is equals to du over negative 0.028. Now we can differentiate that by pulling out the negative 0.028. Oh, 10, sorry. And then you differentiate at u is equal to e to the u from 0 to 8. And now we need to substitute u back into the function here. So when you put in a calculator, so the present value of this business is the present value of this business 672,500, which is more than the asking price, 613,000. So that means it's a good deal for you to invest this business with 613,000. Okay, so here's another example. A company is considering purchasing a new machine for its production floor. The machine costs 65,000 and the company estimates that the additional income from the machine will be constant 7,000 for first year and will be increased 8,800 each year after that. In order to buy the machine, the company needs to convince that it is paid for itself by the end of 8 years with the additional income. Money can earn 1.7% per year, compound continuous, should the company buy the machine. So if you take a look, this function is separate into two parts, the earning incoming function. The first part is the first year, the income is going to be, this is the year, it's going to be a 7,000, and after that the second year is going to be increased until the 8th year. They're going to increase 800 each year. So now how can I use a function to represent these changes? So that means the first year the income function is going to be different than the rest of the 7 years. Look at this. From the second year, starting from the second year, the income is going to increase 800 each year. So that means the income function is going to be a linear function and the rate of change is going to be 800, right? So that means the first step is I want to figure out what is the income function look like starting from the second year to the 8th year. I shouldn't say starting from the second year. It's more accurate. I should say starting from the end of the first year to the 8th year. Okay, so since we know that the first year is 7,000 and after that it's going to increase 800 each year. So that means it's going to be a linear function. However, we don't start with the first year. It's starting from the second year. So the continuous income function from the second year to the 8th year look like this one. Okay, So that means the present value has two parts. The first part is from year 0 to by the end of the first year, it's going to be 7,000 e to the negative r is going to be negative 0.017 times t at dt, plus the second part, which is starting by the end of the first year to the 8th year, and the income function is going to be a linear function. 7,000 plus 800 times t minus 1, this whole part times e to the negative 0.017 t at dt. And when we calculate this one, this should equal to $17,166. And the asking price, the price tag is 65,000. So that means the asking price is cheaper than what we estimate, which means this is a good deal. The company should invest or should buy this machine. Okay, so that's it for this application problem. It's very interesting. Let me know if you have other questions. See you next time.